Howdy, howdy. This is Mr. Potter. In our last video, we talked a lot about coming up with ways to compare objects that we had to do differently from comparing our primitives like ints and doubles. The thing is, we can't use less than or greater than or even the equals operator on objects without getting unpredictable results. And we remember with the string class, we saw that we would have two strings that would be at the same memory location. Sometimes they wouldn't be in the same memory location, and so I didn't get consistent results. We had to use the dot equals. And similarly, I didn't even have the option of comparing two strings with less than or greater than. I had to use the compareTo method in order to compare those. So we're back here at our fraction class, and I want to talk about how we would implement these methods in our fraction class. So the first thing I want to do is I want to talk about how would we discuss if two fractions are equal. So that's what we're going to do is, when are two fractions equal? And of course, one way to look at it would be to say, if the first fraction's dot get value was equal to the second fraction's get value. But we discussed when we were talking about doubles that we really couldn't test for equality due to floating point errors. So we always have those decimal places out in the 12th or 13th decimal place. Those numbers didn't always match up, and Java would tell us that these two fractions weren't the same, even if I'm dealing with something like 3/4 and 6/8, which are clearly the same fraction, but the division would give us different results. So that's not the best way to look at this. And so we're going to have to find a different way to do this. I'm going to go ahead and do the method header for it. Of course, I want everyone to be able to see if fractions are equal, so I'm going to make it public. And of course, they're either equal or they're not. So this is a Boolean method. And I'm going to call it equals. Now, the thing is, I have no idea what they're going to compare my fraction to. It could be anything. And so we're going to compare it to a generic object. Now, object is one of the most basic classes in Java. And when we talk about inheritance and polymorphism later in this series, we're going to see a lot more about object. For right now, just realize that everything is an object. But if it really is a fraction, we should be able to cast it as a fraction. If it's not a fraction, then there's no way that it could be equal. And so what we need to do is see, okay, is this thing that we're looking at, this object O, is it really a fraction? So I'm going to use a conditional statement, and I'm going to ask if O is an instance of the fraction class. And so this is the way that I can ask Java if this is a fraction. And if it is a fraction, then I can call it a fraction f, and I can actually cast it as a fraction. So in other words, instead of dealing with some object O, I'm dealing with a fraction, which I'm calling f. And then, now I can worry about when fractions are equal. And normally when I think of fractions being equal, I want them to have the same numerator and the same denominator. But because of the reduce method, which we've got right here, that isn't always necessarily the case. But if I had a common denominator, they would be the same numerator. And earlier, when we were talking about our addition method, we talked about how to find a common denominator just by multiplying these. And then we could cross multiply the first denominator times the second numerator, and the second denominator times the first numerator. And if these expressions were equal, then we would know that our fractions would have to be equal, because they'd have the same numerator over our common denominator, just like we had for the addition method. So what I'm going to do is I'm going to say if, and I'm going to say fraction, well, fraction is f. So if f dot get numerator times, now I need to refer to myself. And one of the ways that we refer to ourselves is we use the this object. So this dot get denominator. So in other words, if I take f's numerator times my denominator, and it happens to be equal to my numerator, times f's denominator, and if that's true, then we must be equal, and we're going to return true. Otherwise, we're going to return false. And then if I make it outside of here, if I make it here and I hit an else, then if I hit this else, that means we must not have been a fraction. And it can't be equal. So I'm going to have to return false in any case. So this is one way that I could do this. I can write this a little bit shorter instead of actually testing this, because this is a Boolean expression. I can just say to return the result of that, in which case I don't need this stuff here. If it's true, I'm going to return a true. And if it's false, I'm going to return a false. And so it just saves space to write it like that. Since I'm trying to test a Boolean expression, this is a Boolean expression here, I just want to go ahead and return it. And then, of course, if it's not a fraction, if it's a bug, or if it's a point, or if it's any other object, if it's a string, there's no way my fraction could be equal to it, and so I just say false no matter what. So this is our equals method. So I'm going to go ahead and compile this, make sure there's no egregious errors in there, just one, where apparently I didn't put the semicolon, but I got rid of the if. So I'm going to compile this, and I'm going to go to my fraction runner, and I'm going to create some fractions. So I'm going to say fraction A gets new fraction, and I'm going to have this be 15 over 20. And I'm going to say fraction B gets new fraction, and this fraction is going to be 6/8. So notice that this top fraction A is 3/4, and this bottom fraction A is also 3/4. And so what I can do is I can system.out.println is A equal to B, and I can say A dot equals B. So in other words, if I run this, is going to say is A equal to B, and it's either going to tell me true or false, depending on the result of the equals method. And notice I say if A equal to B, and it's true. If I were to change this to say 6/7 instead of 6/8, now I'm dealing with a different fraction, and that calculation is now false. So I'm going to leave it like this for a second while I talk about my compareTo method. So I want to analyze it the same way. How do I compare two fractions? So I'm going to do public. Remember that the compareTo method should return an int. And I'm also going to have an object. I have no idea what I'm going to be given. So I need to prepare myself for that. And I'm going to prepare myself the same way. I'm going to see if what I'm dealing with is an instance of the fraction class. And if it is, then I want to create a fraction called f, and I'm going to cast O as that fraction. And then I need to think about what compareTo should do. So the thing is, my compareTo method should return a negative if this is less than my fraction. Oh, and it should return a positive if this is more than my fraction. And it should return 0 if they are the same. So I want to look at this. If I take the same idea as the common denominator, but I was to subtract it, looking at my subtract method up here. If I subtract a larger fraction from a smaller fraction, I ended up with a negative number. If I subtract a smaller fraction from a larger fraction, I ended up with a positive number. And if I subtracted a fraction from itself, in other words, if I subtracted two fractions that were equal, I ended up with a numerator of 0. So this subtract method really is our clue of how we should approach this. So I should say an int called compare is going to get this dot get numerator times f dot get denominator. I'm still doing the cross multiplying idea. The idea is that if I have a common denominator, the difference in the numerator should be the difference that I'm returning. Minus this dot get denominator times f dot get numerator. And if, and then what I want to do actually is just return compare. Because this value here that's stored in this variable compare keeps track of whether it's negative, whether it's positive, and if they were the same fraction and I subtracted them from each other, I'd get 0. So again, I don't want to create a variable, I just want to actually return it. So this is going to return a negative number if it's less. It's going to return a positive number if this is more. And it's going to return a 0 if they're the same. Which, of course, leads to our else. So if I'm not a fraction, here's where I'm into a conundrum. I remember that the double class had something called not a number. And that really would be the most appropriate thing to return, because not a number is neither negative nor positive. Even the infinities that we had in the double class were positive infinity or negative infinity. But the integer class does not have a not a number that we can use. So what I'm going to do instead is I'm going to cause the computer to say, look, I can't compare these. It's going to cause an error. And so to force ourselves to throw an error, I'm going to throw a new class cast exception. Now, the thing is, the compareTo method is supposed to throw an exception if what we're comparing are incomparable things. And so this is how I need to do it. Now, there's one more thing that we have to do for this compareTo method to truly work. And the one other thing we have to do is up at the very top. And again, we'll explain this in more detail when we're in our polymorphism section. But I need to put implements comparable. And what this allows us to do, because I'm implementing comparable, is it allows other objects to compare themselves to us. So I'm going to go ahead and compile this. And I've got an error in here. What's my error? Return. I don't want to return compare. I just want to return the result of this calculation. Yeah. Okay. So now that should compile with no issues. So now I want to compare the fractions that we had. So I'm going to system.out.println. I want to compare A to B using the A dot compare to B. And I want to do the same thing comparing B to A. Using the B dot compared to A. And the thing is, because we're talking about two fractions comparing themselves to each other, they should be the same value. That number part should be the same. The only thing that should be different are the signs. One should be positive and one should be negative. If A is smaller, then A should be negative. And if B is smaller, then B should be negative. Now notice, I'm looking at 15/20, which is about 0.75, and I'm looking at 6/7, which is about 0.8. So A is going to be my smaller fraction. And if I run this, notice it says if A equal to B, that's false. And when A is comparing itself to B, I get negative 15. And when B compares itself to A, I get a positive 15. Notice that what we're doing is we're really saying 15 times 7 is 105. And 6 times 20 is 120. And they're 15 apart. So that's truly what's happening here, and that 15 is the 15 from our common denominator. If I was to subtract these fractions, I'd either get a positive 15 over 20 times 7, 140, or I'd get a negative 15 over 140. And if I make this tweak one last time, if I change this to an 8, so now this is a 3/4 fraction, this is a 3/4 fraction. When I run it one last time, then notice that my A and B are equal to each other, and so my compareTo returns a 0, as it should. So the idea is that we're building this fraction class to be a fairly robust class. So we can do a lot of things with it. We can create new fractions, add, subtract, multiply, and divide. We can reduce. We can compare them to each other. We can compare them to other objects, which, of course, they shouldn't be equal to. But we're making this a class that's very, very robust. And that's really kind of the idea for this first 6 weeks project. So, once again, this is Mr. Potter. Thank you for watching. Have a great day.